Welcome back, Year 9. Obviously, you're enjoying mathematics so much you've come back for more, and that's fantastic to see. Well, today we're going to be starting our laws for indices. They're called index laws. Remember, indices or an index, they're just names for powers. And we've got many laws we need to go through. Today we're going to cover the first two laws for indices, and they're ones that you're going to need to use repeatedly, so I'd like you to learn them off by heart, how they work. Now the first law is called the multiplication law for indices, and I'll just refer to it as law 1. So it's what happens when we multiply when there are indices or powers involved. Now notice, m is a power, n is a power, and underneath both of those powers we have base numbers of a. Well, if you have a base that's the same and your powers are above the bases, you write the base down and add the powers together. Let's see how that actually works with an example. Now, the way I'm about to set this out is not the way we'd normally set it out. I'm going to do it the long, old-fashioned way first, and then we'll talk about how we can abbreviate it. 2 to the power of 5 means 2 times 2 times 2 times 2 times 2. 2 to the power of 3 means 2 times 2 times 2. So let's write it out like that. So 2 to the power of 5, that's multiplying 2 by itself 5 times. 2 to the power of 3, multiplying 2 by itself 3 times. Now, how many 2's have I got here? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to abbreviate that by saying I've actually got 2 to the power of 8 because I'm multiplying 2 by itself 8 times. Now the index law, the first index law, says if you have the same base number, we've got the same base number of 2, so we write down a 2, look at the two powers, you've got a 5 and you've got a 3. Add the powers together, 5 plus 3 adds to give 8, and there's your answer. It saves you having to write it all out and figure out how many 2's you've got there. Let's try the next one. Part B. 7 to the power of 10 times 7 times 7 to the power of 14. Now 7 has a power above it here in the first part. The 7 on the end has a power above it, but what about this 7 in the middle? I can't see a power above it. So if you ever have a 7 or any number without a power above it, you can think of it as having to the power of 1 because there's one number there. Now the shortcut for this would be now we have the same base number of 7, so because we're timesing, when we're multiplying with indices, we look at the powers and we add them. 10 plus 1 plus 14. 10 plus 1 plus 14, 10 plus 1 is 11, 11 plus 14 is 25, so that's the same as multiplying 7 by itself 25 times. Now let's add some letters. Now when you have something like this, you've got 2 in front of your a cubed and a 5 in front of your a to the power of 4. The 2 and the 5 have nothing to do with the powers. The powers are only above the letter a. So what we can do is we can actually think of the question as being like 2 times a cubed times 5 times a to the power of 4. There's like a times between the number and the letter. If I look at that, I can say 2 times 5, I know 2 times 5, that's just 10. Let's look at the indice or the power parts, or the index parts. Now, I've got an A and an A, they're my base numbers. Look at the powers, 3 and 4. 3 plus 4 is 7. So 2 times 5 gives me the 10. A to the power of 3 times a to the power of 4. Write down a, look at the powers, 3 plus 4 is 7. A to the power of 7 goes after the 10. That's my answer. Well, let's try and expand it a little bit, make it a little bit messier. The rules are still the same though. Look in front of the m to the power of 5, it's a number 3. In front of the n to the power of 4, it's a number 2. In front of m to the power of 11, it's a number 9. There's nothing in front of the n to the power of 7, so it's like a 1, but we don't need to write it. So I could actually split that all up if I wanted to. Normally we would not write this. Normally we just think it, and we go 3 times 2 times 9. Now if I look at this, 3 times 2 times 9, calculator, or if you can do it in your head, fantastic. 3 times 2 is 6, 6 times 9 is 54. So we get our 54 there. Now let's look at the m's, because you can't multiply m's with n's when there's powers above them. So look at the m's. They have the same base, so I can write down the letter m. How many have I got? We're timesing, so we plus the powers. 5 plus 11 is 16. Let's look at the letter n. They're both the same base of n. Look at the powers, 4 and 7. 4 plus 7 is 11. So there's our answer. 54 m to the power of 16, n to the power of 11. Now, you don't have to have numbers in front of your letters. That's okay. When I look at this particular question here, remember, x has a 2 above it, y has a 4 above it, x has a 5 above it. What's above that y? The number 1. So now I can look at my x parts, x squared, x to the power of 5. When I'm timesing, I plus the powers. 2 plus 5 is 7, so I write x with a 7 above it. When I'm dealing with my y parts, look at the powers, 4 and 1. 4 plus 1 is 5, so y to the power of 5, finished. With these questions, once you start to learn how to get the hang of it, you pretty much just write the answer down straight away. There's no working involved with these. You just process it in your head by adding the powers. Now that was law 1. Law 1 said when you times, you plus the powers. Law 2 says that when you are dividing indices, same base of a, and they've both got powers above them, when you are dividing, you write down the base, and then you minus the powers. It's always the first power minus the second power. You can almost see like a minus sign in amongst a division sign there. Let's try some examples. It says, first of all, write it in expanded form, then evaluate. This is so we can see the second law in action. So 2 to the power of 5 in expanded form means 2 times 2 times 2 times 2 times 2. And 2 to the power of 3 means 2 times 2 times 2. So this is what it actually means in expanded form, because I didn't follow the instructions when I typed this into my calculator. It wanted me to do this. 2 times 2 times 2 times 2 times 2, all over 2 times 2 times 2. So that's in expanded form, and then evaluate. But before we evaluate, we could actually look at that and go, hey, those two 2's cancel. There's a pair of 2's that cancel. There's a pair of 2's that cancel. We're just left with that, 2 times 2. Now the shortcut when you are dividing, and that's what a fraction is, 2 to the power of 5 over 2 to the power of 3 means 2 to the power of 5 divided by 2 to the power of 3. When you're dividing, write the base number down, do the top power minus the bottom power. 5 take 3 is 2. And 2 squared is 4. Which means that the answer should have been written like this. So I've expanded it there, and I've evaluated it there. But realistically, I'm never going to ask questions like that. What I'm going to do is just say, use the second law for indices. So if you're using the second law for indices, you just minus the powers. So when we've got letters, we're dividing. We've got letters that are common, k and k. Look at the powers, 10 and 3. 10 take 3 is 7. So it equals k to the power of 7. Let's try doing this one again. Now, dividing. But number 18 divided by number 9. Well, that's a separate thing. Now, number 18 divided by number 9. 18 divided by 9 is 2. Now let's look at the a's. Both a's. The powers are 7 and 2. When you're dividing, you minus the power. 7 take 2 is 5, so you get a to the power of 5, and there's your answer. Let's try our second one. Now, I don't want to write it in expanded form and evaluate, so I'm going to cross that out. I'm just going to solve this question. Simplify is what I should be saying, not expand and evaluate. Righto, let's have a look at it. when I look at this particular question here, I can see the number 10 and the number 25 out the front. I know 5 goes into 10 and 5 goes into 25. So I can actually do that part. The letter P's, this bottom P, whoops, bump the iPad. There we go. This bottom letter P, because there's no power above it, I can put a 1 there. Now let's look at it. 5 goes into 10 twice. So I can actually go 5 goes into 10 2 times, 5 goes into 25 5 times, and that's where my 5/2 comes from. Now, for harder fractions, when they're really messy, just type 25/10 in this case into your calculator and see what it cancels down to, 5/2. Let's look at the powers of P. When we're dividing, we minus the powers. So for the P letter, 6 is on the top, 1 is on the bottom, 6 take away 1 is 5. The answer is always written on the top of the fraction when you're dividing. Now look at the letter Q. The power of Q on the top is 8, the power of Q on the bottom is 7, 8 take 7 is 1. So we get Q to the power of 1, and we don't actually have to write that 1, we can just write Q. Normally that's what we would do, just write Q. Let's try this one. Now, you could start cancelling and start saying, okay, look at that. 5 goes into itself once, 5 goes into 25 5 times, 5 goes into itself once, 5 goes into 10 twice, 2 goes into itself once, 2 goes into 8 4 times. You could cancel it down like that, or you could just put it into your calculator. And if you put it into your calculator, I'm just going to erase those. If you just put 25 times 8/10 times 5 into the calculator, then you get 4. Now let's look at the letters. For the letter P, P to the power of 6 on the top, P to the power of 1 because we can put a 1 there. 6 take away 1 is 5, so you get P to the power of 5. Let's look at the letter Q. 8 on the top, 7 on the bottom, 8 take away 7 is 1, so it's Q to the power of 1, or just Q. Don't write the 1 normally. Again, let's just look at this and break it down into simple parts. Let's look at the number parts, the 2, the 18, and the 12. You can do that on your calculator, 2 times 18/12, or you can do it in your head possibly. 2 times 18 is 36, 36/12 cancels down to 3. So I know I'm going to end up with the number 3. Let's look at the powers of y. Now on the top, I have a times sign. Remember law 1 says if you're timesing indices, plus the powers. So I've got 4 and 9, and because I'm timesing, it'll be y to the power of 13. On the bottom, I've still got y to the power of 7. The 12's gone because all of those 3 numbers cancel down to 3. So I used the first law when I'm timesing indices to change that y4 and y9 to a y to the power of 13 by adding the 4 and the 9. Now I'm dividing because there's a fraction. I've got y's. So when you're dividing, you minus the powers. 13 minus 7 is 6. So the final answer is 3y to the power of 6. Right, that comes to the end of our examples. It's time for you to do some questions. Please don't get too excited. I know you love doing this. Just settle down and just do the questions. Have fun.